Hey everybody, this is Larry. This is day, I don't even know, 18 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe, and join me in Discord. Let me know what you think about today's problem, merge intervals. So given an array of interval, you're trying to merge them, okay? Okay, so I generally um, like these problems, and there are a couple ways to do it. So depending on the constraints that they give you, you might or might not need to sort already, because then there might be linear time algorithms depending on the variation of the merge intervals that you get. But in this case, it seems like it's just generic. So then you can't really help around sorting, I don't think, because combining adjacent ones are not enough because you might need to combine the first or the last. So you always have to sort. So the way that I always do it, to be honest, generally, as much as I can, is by the sort line the line sweep algorithm. Sorry, line sweep algorithm, the sweep line algorithm, or sometimes I call the events algorithm, where you just go from left to right where some events happen, right? And we get to define these events, and those events will allow us to figure out what almost like a finite state automata. As you kind of change the states changes, different things can happen. So that's what we're going to do for this problem. Let's do that here. I think, to be honest, I probably have done this video a couple of times. So, but yeah. So basically, there are two type of events in an interval problem, which is why I like it. There's the open or the start of an interval event, and then the end of an interval event, right? So we could kind of parse. Let's have an events list. Let's parse for start and in intervals. What do we want to do? Well, we want to put in a start event, and we start it at the start. And for me, I always conventionally write +1, because depending on what you want to do and depending on what you are doing, you may do different things. But for me, +1 is shorthand for beginning an interval, because the sum of the interval starts gives you the current number of intervals. And similarly, I like to write -1 for the intervals. And here's the thing that I would think about for these type of interval problems. It's seeing whether it's inclusive or exclusive on both ranges, and how do you handle the overlaps and so forth, right? Like for this case, you see that they are actually inclusive, and you have to consider them as overlap and merge them, right? So there are certain things to handle there. We'll talk about that when we get there, because we might think about combining events to make it simpler. There are other ways to hack around it as well. We'll see how I feel. But now that we have the event, we sort it. And as we talked about, because in this sorting, it's the way that I think about it is that for each event, it sorts by the beginning, or sorry, when the event happens first. That's why we use a tuple, which is the start or the end, and then the event, which is the +1 or -1. But because of the way that we handle it, we actually because -1 comes before 1, obviously, in the number line. When you sort it like that, then the negative comes before first, right? So that is a little bit of an edge case that would come up, because if you look at this problem or this example, your event will be something like, there's a 1 start 4 end 4 start 5 end, right? But what you actually want is, and this is a little bit tricky, because you want these two to cancel out ideally. But another way to do it is just maybe put this here, so that you sort it this way, so that the overlap, so that it handles the overlap, because there's no case in which there are no overlaps, right? So that you want to greedy by that kind of overlap in that sense. Yeah, and there are a couple of ways to do that. You can either sort it differently, or another way to do it is just for an n, because we want to include 4, we can make the ends exclusive by just adding 1, right? So we make this 5, for example. So we add this to 1, then we will, and also this goes to 6, for example, then we will always get this property as well to handle these tiebreakers. Okay. So now that we did that, and you could also, if you want to do non-integers, you could do something funky as well, like maybe, put the ends as like 4.5 or something if you want to be funky. But yeah, so that's the way that I'm going to handle that. And then now that I have the event in sorted order, all we have to do is parse them, right? So now let's get the merged intervals as the results. Let's return that. And then now let's do for let's see, right? Let's do, what's it called? Location, maybe? Naming is always tough. You can name it different things. But yeah, let's just call location and then the event in events, right? So now we want to keep a running counter. So that's what I'm going to do, which is, and that running counter tells you in this point in time how many intervals are inside this current point. So we have current count, say, is equal to 0. And we just have to do event plus equal to current count. And now we have, this is the finite automata part of the problem, which is, well, what are the things that we want to capture, right? Well, we want to capture 2 events, which is from 0 to 1, because that means that we begin an interval, right? We begin at least a new merge interval, because the other states don't really matter as much. Because if you go from 2 to 3 or 3 to 4, it doesn't matter because it all gets almost like flattened and compressed to one interval anyway. But the only one that matters is from 1 to 0, and as you can guess, the other one that matters is from 1 to 0, because now it dictates the end of an interval, right? Okay, so given that, now we just have to check those 2 cases. Right? If event is equal to 1, that means that it went from 0 to 1 because there's no, oh, well, that's not true. And oops. Yeah, if event is equal to 1 and current count is equal to 1, then, you get this situation, and we want to begin an interval. So what does beginning interval mean? Well, let's just keep track of the beginning interval, which is now, right? So let's just call start is equal to location. So let's have a start is equal to none. And then we also check the 1 to 0 case, which is if event is equal to 0 and current count is equal to 0. You could simplify these if statements, but sorry, this is -1. You could simplify these if statements, but I put it out here for symmetry reasons so that we can kind of see what it is. And then now, the location that we're processing is the end of an interval, but keeping in mind that we added 1 to it because it's an exclusive range. So the last part of the segment or the interval that's inside actual intervals is location -1. So then now we can set n is equal to location -1, and then now we do a merge intervals dot append start n. I think maybe I have to return a list. Okay, fine. So this is actually a list, but you get the same idea. And then now we want to reset start is equal to none. So that's pretty much it. I'm going to test right now. We'll go over the complexity real quick. And clearly I messed up somewhere, but that's okay. Oh, whoops. I don't know why I did it this way, but I just mixed up this backwards. Silly mistake. I am doing this live, so it's not like, nah. So this is not prepared. This is just me thinking on the cuff. Everything I explain is live. It's just that I've done this farm a few times, either here or elsewhere. But yeah, so this looks good. Let's try the 0 case, because that's always a case, and then maybe a case where one is completely within another, just for funsies. And you could come up with more cases, but for me, okay, that's fine. And for me, it's just that, I'm a little bit confident. But that said, I have been confident and wrong before, so definitely. But I'm just doing this in the interest of time. But at home, definitely test more cases. Yeah, cool. So what is the complexity? This is accepted. So what is the complexity? Well, this gets dominated by this event dot sort, so it's going to be n log n no matter what. But other than that, we put events, which is two times n, which is O of n, and for every event, we do linear, or sorry, for a constant amount of time per event. So that means linear time for the processing, but overall n log n and linear space. Let me know what you think about this problem. Let me know about the solution, and let me know if this is new to you for intervals. I love this approach. I might yeah talk about this more, but I will see y'all another day. Bye bye.